everyone, welcome back to Study Sprint. Today we're diving into one of the most fascinating families on the periodic table, Group 1, the alkali metals. These elements are incredibly reactive, super soft, and play a huge role in our everyday lives. So let's explore what makes these metals so unique. Group 1 of the periodic table is home to the alkali metals. There are 6 elements in this group: lithium, sodium, potassium, rubidium, cesium, and francium. They all have one thing in common. Each has one electron in its outermost shell, and this single electron is the key to their reactivity. So let's list them out from top to bottom. Lithium, sodium, potassium, rubidium, cesium, and francium. Notice how they increase in atomic number as we go down the group. The atomic number of lithium is 3, sodium 11, and potassium 19, and it keeps increasing as we go down the group. But that's not the only trend. These metals get more reactive as we move down the group. Let's break down their properties to see what makes alkali metals special. Most metals are hard and dense, right? Not alkali metals. These guys are so soft, you can cut them with a knife. Lithium, sodium, and potassium are actually less dense than water, which means if you drop a piece of them into water, they float. The alkali metals have low melting and boiling points compared to most other metals. Now, one of the coolest things about alkali metals is how they react with water. When you drop sodium, potassium, or any of its cousins into water, it creates an explosive reaction, forming a metal hydroxide and hydrogen gas. Sodium reacts with water to form sodium hydroxide and hydrogen gas, which is highly flammable. This is why the reaction often results in sparks or even small explosions. And if you try this with potassium, rubidium, or cesium, the reaction becomes even more violent because the reactivity increases down the group. Now, alkali metals don't just react explosively with water, they are also highly reactive with oxygen. In fact, when exposed to air, alkali metals quickly form oxides on their surface. That's why freshly cut alkali metals look shiny at first, but they dull and tarnish within seconds. When lithium reacts with oxygen, it forms lithium oxide, which gives the metal a dull white coating. The interesting part is that the type of oxide formed depends on the size and reactivity of the metal. As you move down group 1, from lithium to cesium, the metals are more likely to form peroxides and superoxides because they react more vigorously with oxygen. These reactions with oxygen are why alkali metals are always stored under oil or an inert atmosphere. This prevents them from reacting with air and forming oxide, or worse, igniting spontaneously, especially for more reactive elements like potassium, rubidium, and cesium. Now let's talk about one of the most dramatic reactions of alkali metals, their reactivity with chlorine. Alkali metals react vigorously with chlorine gas to form metal chlorides, which are ionic salts. These salts are all white, crystalline solids and dissolve easily in water. The alkali metals react more vigorously with chlorine as we go down the group. That is because it becomes easier to lose the single electron in the outer shell to form ions with a positive 1 charge. Here's what's happening at the atomic level. Remember, alkali metals have 1 electron in the outermost shell. Chlorine, like all halogens, is missing 1 electron to complete its outer shell. When they come in contact, the alkali metal loses its outer electron to chlorine, forming a positively charged metal ion and a negatively charged chloride ion. This electron transfer results in an ionic bond, which is very strong and creates stable compounds. Now let's talk about trends in reactivity. The elements become more reactive as you go down the group, and this is because as you go down group 1, the atoms become larger. The outer electron becomes further away from the nucleus. The force of attraction between the nucleus and the outer electron is reduced, so making it easier to lose the outer electron. Even though alkali metals are super reactive, they are incredibly useful in everyday life, just in compound form. Sodium. Sodium is a key part of table salt, sodium chloride. one of the most essential compounds in our diet. It's also used in street lights to create that bright yellow glow. Lithium. Lithium is critical in the production of batteries for our phones, laptops, and even electric vehicles. It's lightweight, stores lots of energy, and is revolutionizing green technology. Potassium. Potassium is found in fertilizers, helping plants grow. It's also crucial for our body's nerve and muscle function. So bananas aren't just delicious, they're packed with potassium. So that's a quick dive into the exciting world of alkali metals, from their incredible reactivity to their everyday uses. Whether it's the lithium in your phone battery or the sodium in your table salt, Group 1 elements play a huge role in your life. Thanks for watching. Please don't forget to like, share, and subscribe my channel for more science and maths videos.